Because I'm going to try to iron out as much as I can today. So I'm going to pull this over, pull my handy-dandy calculator up, move this over here. And I hope y'all can see this much. I'm going to try to do it this way. Okay. Now, so far we've talked about several things, and I think it's fair to you what I'm going to test you on, because that's what you're wanting. You want to know what I'm going to test you on. Okay, I'm going to test you on margin of error. I'm going to test you on a confidence interval. And I think, I can't remember what section that is. That's where you put P in between the lower bound and the what? Upper bound, based on a confidence what? Confidence level. And also margin of error. Make sure you can find the margin of error. I gave you all that stuff. And how big should N be for a 95% confidence level, 92% confidence level. That's the stuff that we went over at the first part. I think it's 8 and 9. Okay? But I'm not going to test you on all the stupid stuff in 8 and 9. I'm just going to test you on those things. So the problem that we did in class are the problems that I'm worried about. Okay? So that's 8 and 9. It could have been done in one section, but they spread it out through two or three chapters or whatever, 2 or 3 sections. So that's what I'm going to test you on there. And I gave you the formulas. I don't have the formulas for that, but I just threw that in there. And then on chapter 10, I'm going to test you on hypothesis testing. And for the next, basically for the next week, well, up until the Thanksgiving holidays, I'm going to give you problems that I pick, and we're going to go over them in class. So the book, and pretty much, I don't know about the homework yet, but I don't know what I'm going to do with the homework. I'm going to test you on what I cover in class. Everybody got that? So do you need to have conniptions over homework problems? No. I don't even know if I'm going to count the chapter 10 homework yet. I may make up a new homework, okay? It may be called chapter 10 homework, and I may just put problems in there that I want you to learn. Does that make sense? Because I don't want you to learn a concept, then go to your homework and be what? Confused. And that will happen in this chapter, so I'm not going to do that. So I wouldn't do any chapter 10 homework right now. All right? Hypothesis testing first starts off with, let's see, p-values. You can test with p-values. Okay, that's one way to test. You can test with z and t. Okay, and I'm going to give you when and where. Now the p-value should state, find the p-value in the problem. Okay? A p-value means that if they put a homework problem up, or I give you a test problem, they're going to say find the p-value. That's fair enough. And then you find the p-value. That's a different method. I don't even think we've gone over it. We're going to go over it today. Because in all of those dang slides, you can't tell what they're doing because of all the writing they got. So we just put the slides away. All right? The z-test, usually you use the z-test when the population standard deviation is known. Now write that down because that's very important. Okay? It'll say it in the problem. It'll say sigma, or the population standard deviation, is 2.1. If that's given, then you're going to use a z-score. If it's not given, you're going to use a t-score. Okay? Now, when you do hypothesis testing, and we're going to go over the formulas with all these. I'm going to go ahead and on the next slide, I'm going to write the formulas. But I just want everybody to know that that's what I'm going to test you on. I'm going to test you on a p-value problem. I'm going to test you on a z-value and a t-value. I'm not going to go to chi-squared, because chi-squared you'll get when you do, more statistics, more classes. But I will put the fourth down here, and you don't have to, the chi-squared test. The chi-squared test is what you use that whenever you have more than one set of data. Okay? But you don't need to know that. That's for later. In case you see it. Okay? So I'm going to try to put this in some kind of perspective to where you won't be confused by looking at 20 million slides. Remember, I think this is chapter 8.1, 8.2, 9.1, 9.2, I think, pretty much. That's what that is. And this is chapter 10. Okay? Now, the formulas for chapter 10 are basically the Z formula, which is p hat minus p divided by the square root of pq over n. And that's used when you're given proportions. Remember x over n, p hat, x is equal to 50, n is equal to 100. Or they give you some kind of percentage, probability, or a decimal. Everybody with me? They give you something like a proportion, and that's it. Now, how do you know that you're not supposed to use the other formula for Z? Well, they're not going to give you a standard deviation. They're not going to give you a mean. They're not going to give you all of that stuff. Everybody with me? They're just going to give you x is equal to 10 and n is equal to 100, and I want a 95% confidence level. Everybody with me? That's a proportion test, and that's what that's called, proportion. All right? If they give you all the other junk and give you sigma, which is the population standard deviation, and they give you mu, or they give you x bar, and they give you all that stuff, s, all that. If they give you all of that stuff, then that's called a z-test. And that is going to be z is equal to x bar minus mu over, and they give you sigma, so that's going to be sigma over the square root of n. Now, what if they give you a question and they say mu is equal to this, s is equal to this, and x bar is equal to this? Then you don't have what? Sigma. If you don't have sigma, or sigma is unknown, then you use the t-test. And it's the same formula, except instead of sigma, you put in s, which is the sample standard deviation. So x bar minus mu over s divided by the square root of n. Now both of these, you can use the table, this is the table, or your calculator. I'll show you how to do that today. Again, the slides didn't show you how to use it. They just assumed that you knew how to use it. Here, you use the t-table or your calculator. Now, of course, don't forget the other formulas. You need to write down those other formulas. I've pulled up cheat sheets, and you can pull up a cheat sheet on Google. I would do that if I was you. For those 2 or 3 students that's going to do it, you know, that's a good thing to have, because it's got you need to pull up margin of error. You need margin of error, all those that I listed. Margin of error, confidence interval, finding out n for a confidence interval, all that. And we did that in 8 and 9. I gave you those formulas. You know, there's another concept of taking an index card and writing all those formulas down. That's a concept too that some of y'all, 2 or 3 of y'all might use. Okay, so there's the formulas we're going to be using. I might add another one. I don't know if I'm going to add another one or not, but right now, those are the formulas. Everybody with me? So there's one. And that's used when you're just given proportions. Now, they could give you proportions and they say you can find the p-value. We're going to go over some questions like that. And then they give you this. And that's where that test comes into effect. This one you use when n is less than 30. Okay? Also, so if you have sigma and they give you n is equal to 5, or they give you 5 data points and you're supposed to find the average and all that stuff, then chances are you're going to use a t-test. Okay, somebody got a question on those?
For the middle formula, underneath the sigma equals population standard deviation on the left.
Right here?
Yeah, what is all that?
Mu is what?
Mean?
What is the mean of what? It's a Greek letter. What is the mean of?
Population.
Population. What is x bar?
Mean.
The sample what? Mean. What is s? The sample what? Okay? So what's the only thing not given? Or what's the only, I'm sorry, this is given and this is the what? Population what?
Standard deviation.
If the population standard deviation is given with all of this, then you're going to use a z-test.
Okay.
If the population standard deviation is not given, go away. Okay, I don't understand how that's doing that. And n is less than 30, chances are you're going to use the t-test. And you will see when I'm doing these problems, because I went through and I bet I did 15 problems last night, okay? And we're going to keep doing them. And when you see the test and you see my homework that I'm going to make up, you're going to say, okay, I understand this stuff. But if you depend on those slides that we did, and you depend on the homework, then don't even try, because you're going to be confused. Well, most of you will be confused. Capiche? Now, the second thing I want to talk about is what do you do when you actually start a problem? Okay, so this is the formulas you're going to use. So here's what you do when you start a problem. 1, you state, and I'm just going to put state. You write down H of O and H of A. Also, state what your confidence level is, or your significance level. Because the significance level is the complement of the what? The confidence level. If I give you a 95% confidence level, what is the significance level? 0.05 alpha. So state all of that stuff. H of O, H of A, or H of 1, whichever one you want to put, I don't care. Significance level or confidence level. And basically, whatever they give you, you're going to be able to state the other. So that's the first thing you do when you start a hypothesis test. The second thing you're going to do is you're going to calculate significance level. Now, what does that mean? I thought you wrote it up there. No, that's your index card. Remember the index card that you were supposed to put together? find out where you need to be with your index card. Is it a two-tailed test? Is it a one-tailed test? All that stuff. That's where you figure that stuff. Okay? And I'm going to put right here, I'm going to put one-tailed or two-tailed. Now, one-tailed can be what? On the left, or it can be what? On the right, depending on where your hypothesis test, your alternative hypothesis is. 3, find critical value. This is where you're going to use your Z or your T test, or the 3 previous formulas. Okay, now this is where you draw a picture most of the time. Now, some of the stuff that I've seen in the slides, they don't draw a picture. Of course, I don't think some of these people know how to teach, but that's just my own opinion. And then the critical value is the Z based on what you're given. And you're going to put, you're going to put a little part there, and you're going to put the critical value right here, and you're going to shade this part if it's greater than. Everybody with me? Because that is called what? What is this called? The rejection what? The rejection region. If it falls in that region, you reject the what? If it doesn't fall in that region, you fail to reject. Okay, so find the critical value. And 4 is find the test statistic. Find test statistic. Thought I had another. I guess I don't. Okay. And when you find the test statistic, that basically is it. Now, there's a 5th part, state your conclusion. Well, I fail to reject, or I reject the null hypothesis is good enough for me. All right? That's basically it. Now, to find the test statistic, you're going to use the formulas again, but it's going to be based off of other information. Okay? So this is the test statistic, and that's basically, it's either going to fall here, or it's going to fall there. Now, with the p-value, and I'm going to get to that with a problem, you don't necessarily do that. You basically say, if it's too low, I think that I got to learn this slogan, if it's too low, the null must go. You ever heard that before? Okay. If it's too high, the null must fly, meaning that it's okay. I don't know where that came from, but anyway, we're gonna do that. So, has anybody got any questions on how you start it? Okay. So let's start with a p-value. We'll start with a p-value test. All right. Probability, let's see, I want to see one that's really, okay. The probability of obtaining a sample more extra, no, I don't want to use that. Let's use trade, manufacturing, fast food service. All right. Trade magazine said that fast food service times in a drive-through is a proportion, as a population mean. So fast food waiting times in drive-through. I'm not writing all of this, so you can ad lib. Has a population mean of 167.1. Salt Lake City manager. A Salt Lake City manager. And this is a fast food restaurant chain. I didn't think it was that important, so I didn't put it. Okay, so a manager at one of these chains, manager. And I don't know what's wrong with this pen, but it's right halfway. Drive-through policy. She does a new drive-through policy and basically gets the following information. She has a random sample of 70 cars. Okay? She has an X bar that's equal to 163.9 seconds. And of course, this is seconds. And the standard deviation, S, is equal to, the sample standard deviation is 15.3 seconds. And they want to know, is her policy effective? And we're going to use a 0.01 confidence level or significance level. So this is what the question will give you. So what I tell students is write a line under all that, because all of that is given. Now, the first thing you notice is that you do not have, this is not proportion. Why? Because a proportion would just give you what? X and N, or a percentage, or a fraction, something like that. Everybody with me? So this is a p-value. How do you know? Well, the directions will say find the p-value. It'll say, finding the p-value, is her policy effective? Okay? Or the directions will say, in the following questions, find the p-value. Or determine whether to reject or accept the null hypothesis, finding the p-value. It'll say something like that. So, the first thing we notice, or the third thing we notice, is there's no what? There's no sigma. So we can highlight that. No sigma. Now, most of the time, if there's no sigma, you're going to use the t-value. Okay? Now, there is that thing about n being less than 30. And this time it's 70. You could use a binomial distribution, which we did back in chapter 6 and 7, using the NPX feature on your, and we got a problem like that. I've got a problem like that, and we're going to do that. But then in this case, just use the t-value. So here we go. T is equal to x bar minus mu over what's missing? Sigma. So you're going to put in S over the square root, is square root of n? Yeah. Square root of n. So plug and chug. I want you to plug and chug in that one, this one. And you need your calculators, so go ahead and get them out. Everybody's got a phone. You got a calculator on a phone. No coughing in class. Need to lay off the Marlboros. I told you once. Next, you're going to be smoking weed and being a pothead, a deadhead, and all that. You're going to live in a box down by the river. So that's going to be 163.9 minus 167.1 divided by, and that's going to be S. S is 15.3 divided by the square root of 70. And you crank all that out, I got negative 1.75.
Yes, sir.
Okay, now we just took care of the t-value. We just found our critical value. So you can actually draw a picture if you wanted to, or you can look it up in the table. And look it up in the table. Let me go to the next page. Negative 1.75. Negative 1.75. You go to the t-table in your book, and if you don't have one, you need to find it, you need to pull it up, or use your calculator. I'll show you how to do that if I can remember. I think I put how to use your calculator. Yeah, I did. Go to the t-table, and you're going to look up how many degrees of freedom. Well, 70 minus 1 is equal to 69 degrees of what? Freedom. So you're going to look up that. You know that when you pull up the table, and I just have a little, I just wrote a little, the t-table is going to, you pull up 70, because they have 69, they don't have 69 degrees of freedom in the table. So you go to the closest one. Write that down, the closest one. 70 is the one that they have. And if you go to negative 1.75, negative 1.75 falls between 1.667 and 1.994. Okay, now again, if you have a book, you can find the t-table. If you didn't bring your book, then you don't have a t-table, you have no idea what I'm talking about. And that is 0.05 and 0.025. If you go up and look, that's going to be 0.05 and 0.025. So that means that your confidence level is going to be between 0.025 and 0.05. Your proportion or whatever is going to fall between 0.025 and 0.05. What is our p-value? Our p-value is greater than 0.01. Okay? What is this? This is 3 cents. Everybody with me? And this is 5 cents. Our significance level is 0.01. Now see, the p-value test is the one they use the most because you don't have to think too much. Okay? Our significance level is 0.01. Remember what I said? How did I put this? I can't even remember how I said it. I don't even remember it. Got my stuff mixed up. Hold on a second. If it's low, yeah, p-value. I thought it was p-value. If the p-value is low, the null must go. And what does it mean must go? That means reject. If the p-value is high, the null must fly, meaning that it's good. All right, so what is our p-value? Our p-value is between 2 cents, 3 cents, and 5 cents. Everybody with me? So what is 5 cents and 3 cents compared to 1 cent? It's high. So if the p-value is high, then what? We are going to fail to reject the what? Null hypothesis. Fail to reject the null hypothesis. Now, the p-value problems are a little bit different. They're the most used in statistics. You can't go with the 4 things that I showed you with the p-value test. The p-value test is basically you find your z or your t-value, and then you compare it to your significance level. Now, why do you think it's used the most? Because it's the most simple. Okay? So let's look at the p-value and what we did. So let's write it. Let's go back to the previous page, and let's see what we did. We didn't really even state I don't think we did. Yeah, we did. I'm sorry. I skipped that part. Sorry. The null hypothesis, we got to state. The null is right here. Mu is equal to 167.1. And the alternative is mu is greater than. I think I said greater. We said less than in the problem. Less than 167.1, and we got a confidence level of a significance level of 0.01. Okay, so we stated that, and then we actually calculated. This is 2. We calculated our t-score. Calculate t or z. Okay. And then, after that, you looked it up and you found your value and then you compared it. That's it. So, this is not like the regular hypothesis testing. P-value is simple and it's done all the time because it's simple. You compare it to this guy right here. Okay? And looking up a t-value is kind of the same thing as looking up a what? A z-value. Now, how do you use your calculator on this? Well, I'm going to just write it down, and I want you to use your calculator to see if you can get the same thing. But please make sure you write good notes. Okay? All right, so you go to Stat, Test, t-test, and then you're going to have mu is equal to 167.1, x bar is equal to 163.9, Sx is your standard deviation for the sample, 15, I don't know why this keeps doing this, 15.3, and then n is equal to 70, and then they ask you which way do you want to go? You want to go less, because the statement said less, the alternative says less than. And when you calculate all that, you should get a t-value of negative 1.75, and then a p-value of 0.0422, which you go down here and you say 0.0422, and then 0.01, and then what do you say? This is greater, so therefore p-value is more. Okay, p-value is high, so the null must fly. So just circle the null hypothesis, and that's what's valid. So actually, if you use a calculator, it's a whole lot what? Easier. And I will admit to you, I told you this before the semester started, this is the hardest unit. Chapter 10 is the hardest unit, and I think I know why. Because the book makes it hard. Okay? All right, here's another one. So that's a good problem. That shows you how to do it. And then what value you're really interested in is that value right there. Capiche? All right. So, recent survey of 151 postpartum women. Survey of 151 postpartum women say that they get, or the survey says that they get a sample mean of 7.8 hours of sleep. And a standard deviation of 1.4 hours. Does evidence support that women do not get enough sleep? Does evidence support that, having to write that word twice, postpartum women do not get enough sleep? At sigma equals 0.05. So there is our question. So H of O is going to be mu is equal to 8 hours. So what is H of A? Or H of 1? H of 1 is going to be what? Mu is what? Should be less than. Yeah, it's less than. Does not get enough sleep means less than 8 hours. And alpha is equal to what? Alpha is equal to 0.05. Now this is a p-value test, so therefore, is that an important number? Yes, you're going to compare your p-value to that 0.05. So it's got to be less than or greater than a nickel. Everybody with me? Now, you can go ahead and do the t-test because half of you don't have a table. So go ahead and let's see what everything is in the t-test. So the t-test is going to be t is equal to 7.8 minus 8 over 1.4 divided by the square root of 151. Or you can do your calculator, and I'll go to the next page after you finish writing. What is that? I hope it's a movie. So, stat, test, t-test, and you're going to type in, and make sure it says stat. I forgot to tell you that. If it says stat, that means somebody's already figured the what? The information. Like the mean and the standard deviation and all that. What if it doesn't? What do they get? You give you a bunch of numbers. Then you use lists. Doesn't it say list? Data. Okay? Then it'll read L1 or L2. So let me see if I can pull this up. I don't like to use the mouse with this because half the time it messes up. Stat, test, t-test, and you see where it says stats. You want to make sure it says stats because that means somebody's giving you the stats. Hit enter. Well, anyway. And mu is what? 8. And x bar is 7.8. And standard deviation is 1.4. And n is equal to 151. And what do we want? We want less than, right? And enter. And go down and calculate. There we go. So now, we write down all this, whatever, we get negative 1.755, and we got a p-value of 0.04. Well, 0.04 is what than a nickel? So the p-value is low, so the null must what? So reject the null hypothesis. And some of you are saying, okay, this is pretty good, I could do this. No slides. Sometimes it's pretty good, and that's the difference between, oh, shut up you. Okay? Y'all with me on that one? Okay, I lost my last problem. Feeling a little bit better? Well, wait till we get to the other ones, and you're going to feel a whole lot better when we cover all of them. And then you're going to say, good gosh, I'm not going to look at the homework. Well, I don't blame you. All right, next one. In a parliamentary procedure, in parliamentary procedures, definitions, all that stuff, a supermajority I don't know what's wrong with this board. I guess because it's just partial, I guess that's why it's acting up. Is over 60%. Excess of 60%. So if I go to the class and I ask, what color is the sky? And 60% or more of you say blue, then that means it's a supermajority. Everybody with me? Okay. So I want to make sure of that. Because that's basically going to be, what is that? I know. What is this? Not the point. What is that? Percentage. Okay? That starts with a P. Okay? So we're going to get to that in just a minute. All right. So, where am I at? In a poll in 1939, this will get you. This is real. This actual real research. In 1930, I didn't write the footnote, so please don't sue me, okay? In 1935, 1,561 adults were asked, will the U.S. ever fight a country like Japan? Okay? 954 said no. What I tell you all the time, knowledge is what? So this dumbass syndrome that America's been is just the last 10, 15 years. There's a lot of people being ignorant for years. Okay? You don't? I don't know you watch these. Well, I'm one of the stupid asses. All right. In 1954 said no. Does this constitute a supermajority? So this is the question. Does this constitute a supermajority? And I'm just going to put MAG. All right, so we're giving something different now. Do we have standard deviation? Do we have mean? Remember what I told you the first week of class. Failing statistics and probability is not for math. The math is elementary. It's what? Reading. So this is a different problem. So right quick, you automatically pick up that this may be P what? P half. Why? Because you're given an X and you're given an N. So, my hypothesis, my null hypothesis, is that P is equal to 0.6. So we're going to highlight this guy right here. That guy right there, what does the first statement say? It commands something. It says, it's this way or the highway. Okay? A poll is taken and says that a supermajority, or it says parliamentary procedures definitions, say that define a supermajority is anything in excess of 60%. So we're gonna, that's our null hypothesis, because now somebody went out and what? Tested it. So what do? Well, you know you're going to use p hat. Well, first of all, the alternative, and I'm used to writing h. You can put a 1 there if you want to. I don't care what you put. P is what? Greater than what? 0.6. Because that's a success, okay? So we got a major thing up top, and then we've got somebody testing it. Just like we had with the fast food and the what? Drive-thru. Okay, we had something and then something testing it. Now, we're going to use alpha is equal to 0.05. Now, let me go ahead and tell you this. Most, 99% of the problems that you get will be given an alpha. Some way, some form, or given a confidence level. If you're given a confidence level, then alpha is equal to the complement. Really? You got it? 95% confidence level equals 0.05 significance level. All right, so all that's going to be given. Now we got to find p hat. So find p hat, y'all. P hat is equal to 954 over 1939. No, that's not right. 1561. Stick to your notes, Hubert. Well, I wish we could have fun like that. I show a commercial and I get a complaint. 0.6110. Yeah, he was showing movies in class today. Therefore, what is Q hat? Q hat is equal to, I didn't even do it. Somebody tell me what, that's 0.4.
0.389.
Okay, 389. 0.389, thank you. Okay, so now we're going to plug it into the z value, which I gave you a while ago. Now, which z formula are you going to plug all this into? The one with what? P hat in it. Not the one with mean and standard deviation, but the one with p hat. So go ahead and do that. And then I'm going to show you how to do it on the calculator. And then you're going to feel all good about yourself. Yeah, you got it. So Z is equal to P hat minus P over PQ over N. I'm sorry, you're supposed to have Q, not Q hat. I'm sorry. So P hat, Q hat is 0.4. So Q is 0.4. I messed that up a while ago, so fix that. All right, so that's going to be 0.611 minus 0.6 over the square root of 0.6 times 0.4 over N, which is 1561. What was it? 1561. Okay. Crank that out, and you get 0.89. That's basically a z-score. Now we've got to figure, we've got a z-score now. What if you're given a z-score, what do you have to find? Area, thank you. So let's find our area. We've got to draw a picture. Of course, some of y'all won't draw a picture because you know it all, but. So where is 0.89? Well, 0.89 is right in here, right? So 0.89 is right here. So I'm just going to draw this. And do we want above or below? We said we wanted above, right? Okay, Okay, somebody take your handy calculator and go from 0.89, make sure that's right, I think, yeah, the table. Go from 0.89 to, what's this arrowhead called over here? Infinity, which is what? 9999. See what you get. Is it normal CDF or normal PDF? Which one do we use? CDF. So what is 0.89 to 9999? I got 0.1864. Did y'all get that? Huh? 0.1864. So 0.1864. And over here, that's what, if you get in the table, is 0.8133 if you do the table. And then, of course, you got to get the right-hand side. All right, so we got 18 cents there. Everybody see 18 cents? Or technically 19 cents, right? So 19 cents, blank, 5 cents. I'm wanting somebody to interact with me here. So the P is what? The P is high, so the H of O will what? The hell with it. I can't even write. H of O will fly, which means what? You accept the null hypothesis or you fail to reject. So if it'll let me write it, you're going to accept the null hypothesis. Now, let's do it on the handy-dandy calculator. So, stat, test, and make sure you hit one proportion z-test. Everybody got it? And fill it in. Piece of O is 0.6. X is, what was X? 1151? Or X was 954? 954. N was 1561. And what do we want? Less than or greater than? And calculate. It's a miracle. And look, you don't even have to do anything. It gives you the p-value, the second one right there. 18 cents. I'm trying to get as much as I can today, so y'all just don't have convulsions, okay? What I'm trying to do is I'm trying to give y'all a lot of problems in your notebooks, so that way when I assign the homework, y'all, will have enough in your notebook, unless you want to depend on your book. A certain diet, called the zone diet, says 40% carbs, 30% protein, and 30% good fat. 79 were put on the diet. After a year, after 12 months, the mean weight loss after a year, y'all ready? The mean weight loss, so that would be X bar, is equal to 1.6 kilograms. Diet's pretty much worthless. Standard deviation of that group was 5.4 kilograms. Well, if you stay on it for 20 years, it'd be good. Okay? And they want to know if the weight loss, this is what they want to know. A, weight loss, is the weight loss greater than 0? Okay? At a 0.05 significance level. So there's your question. Okay? And is it practical? They want to know, does weight loss have a significance? Is it practical? Well, I can tell you right now, 1.6, that's nice, but it's not practical. So, our hypothesis, null hypothesis, is the mean, the mu, is equal to 0. And of course, the alternative hypothesis is mu is greater than 0 at an alpha of 0.05. So we're going to compare our p-value basically to 5 cents. So we're going to use the t-test here. The reason we're going to use the t-test is they don't give us what? They don't give us what? Sigma. There's no sigma. Where's the sigma? They give us mu. Mu is equal to 0 because they state in the question weight loss. That's part of the question. And they give us x bar and they give us s and they give us a significant level, but they don't give us what? Sigma. So we're going to use the t-test. I'll let you finish writing it down. Go ahead and plug it in the t-test. X bar minus mu over s divided by the square root of n. And we're going to have to use the calculator for the t-test. You can put it in your calculator, or if you got a table, which I don't think any of you. Does anybody in here have a table? Okay, we'll just use the calculator then. Oh, you got it. No, the table. I mean the table with the t-test, a t-table. You need to look for it because you need to know what it looks like. So you need to go on Google, pull up. Is it Sullivan? Is this book Sullivan? Sullivan t-test or t-table PDF, and print it out, and you can put it with your z-table. Why? Because you may have a standardized test question and they give you the table in the question, like they do in some of your homework problems, and you can't use the calculator. So here we go. T is equal to, and I just put the numbers in because I don't have them with 1.6 minus 0 over 5.4 over the square root of 79. Let's see, should be 79. Okay, because I ran out of paper. I can't see what I wrote. I guess it's 79. Okay, and y'all get 2.634.
That's what I got. Yeah.
Okay, so that's your t-score. Okay. Now, if you look up the t-score, I'm going to give you this. Your degree of freedom is going to be what? 79 minus what? 1, which is 78. So you're going to look up the closest number to 78 in your table, your t-table. And that comes up to be 80. You're going to look up 80, and you're going to find the closest number to 2.634, and that is 2.374 and 2.639, I think. And that's at 0.01 and 0.005. Okay, so that's and you go up there, and you go up there because this falls right in there somewhere. Okay, that's your table. So I'm going to put t-table info right here. Okay, so you look up 80 because that's the closest number, and then you go till you find 2.634, and it falls in here between 0.1 and 0.5. So, our p-value is between 0.01 and 0.05. Oh, 0.005, I'm sorry, it's good, fast accurate, sorry. I was thinking about our p-value is between 0.005, which is 1 cent. I'm going to change that, I'm going to write that in blue. 0.01, because that's 1 cent. And 0.01, which is 1 cent. So, does everybody see what I'm saying? Our p-value is around 1 cent. Everybody got that? So, I'm going to say in blue 0.01, even though it's between 0.005 and 0.0, I'm putting 0.1. Blank 0.05. What does that say? I'm sorry.
Less than.
Thank you. Less than. So the p-value is low. So what? So reject the what? Null hypothesis. So there is sufficient evidence, since we're rejecting the null hypothesis, you do lose what? You do lose weight. So after 10 years, you'll lose 16 pounds, which is a good way to lose weight. But some people in our society today, when do we want it? Now. How dare we have to wait? Okay, here's a nerd. This is the last one for the p-values. So somebody tell me how many we done? 5 or 6? How many is this? 7? According to research, proportions of Americans that use the cell phone and no landline is 0.37. According to research, I'm just going to put research equals cell phone usage is equal to 0.37. This means that a person lives on their own, not in the basement, not in their mom and daddy's basement, but lives out on their own, and they do not have a landline, they just use a cell phone. I'm one of them. I don't have a landline. Why? Because I don't appreciate getting phone calls that talk about this and that and this and that. You know, the days of somebody calling your house is just about over. Now it's just robocalls and surveys, and your car's about to fall apart. You need extended warranty. So I don't even use a landline. All right. So it says a survey of 20 to 24-year-olds live on their own. 16 have, okay, I messed up. I don't have an N written on this. Hold on a second. Let me see if I can. Okay, N is equal to 30. Okay, I don't know why I didn't write that in the problem. 30 people were surveyed. 30 surveyed. And these are people that live on their own. Bernie's not going to take care of them. Survey of 30 people, 16 do not have a landline. In other words, 16 use cell phones, do not have a landline. Okay? So that means that what? 24 or 14? 14 have a cell phone and a landline, or 14 has a landline or something like that. Okay? Provide evidence that P is greater than 0.37, or, you know, that that the landline, no landline is greater than 37. I have to read my own writing. Provide evidence that people that have no landline is greater than 0.37 with alpha equals 0.10. So we're comparing now to 10 cent. Now, this problem is the one I told you about, and you need to mark this problem. This problem, since n is so small, okay, and since you can't, if you did NPQ, okay, NPQ would be 30 times 0.37 times 0.63, you get 6. And that's so 30 times 0.37 times 0.63 is less than 10. And that's a rule, and they get 6.933 is less than 10. Therefore, we got to use a binomial distribution. Binomial distribution. Remember, that's NP what? X. Remember NPX? You type it in your calculator. And they're wanting to know how the best way to do this is. Well, the null hypothesis is going to be P is equal to 0.37. And the alternative hypothesis is going to be P is greater than 0.37. Now, to do this, they're basically saying we want to know the probability of 16 or more. Does everybody understand that? Since we want to get greater than 37, we want to know 16 or what? Or more. Because this doesn't say equal to, does it? That doesn't say equal to. So we've got to have 16 or more. So we need to do, and the reason we're doing it this way is because this number is so low. Okay? I doubt very seriously you're going to have a test question like this. But if you're doing a homework problem and they do it a different way, this may be why. So, what do? You got to do NPX, NP16, NP15, ... down to NP what? 1. And you got to add all those up. Now, of course, I'm not going to do it that way because why? That takes too long. Remember the binomial CDF? What does C stand for? Cumulative. And you're looking up to 15. So you can type in NP15 on the cumulative CDF. Is it called binomial CDF? Somebody look it up. Binomial CDF. We don't want to do this. Okay? Binomial CDF, I think it is, and our N is 30, and our P is 0.37, and our cumulative, we're going up to what? 15? I think that's what I put in. Yeah, 15, because you don't, yeah, it's not equal to it. So that's 15. Now somebody tell me what this gives us. Go away. This gives us from 1 to what? 15. Does everybody understand that? But we don't want 1 to 15. We want what? 16 or what? So what do we need to take when we get this number? Complement. Let's draw it on the number line. Remember I told you, if you ever get confused, draw it on the number line. 0, 1, 2, ... 15, 16, 17, 18, and it goes up to what? 30? Everybody with me? Okay. What are we finding right here? We're finding up to what? So if we want 16 or more, actually it's not you don't have 0.5 people or 0.5, you know, so it's really this. It's really the dots. Remember the dots, you don't have fractions in there. So if I want 16 or more, somebody tell me what I'm going to do when I get that number. When I get this number, what am I going to do with it? Somebody said it a while ago. Find the complement. 1 minus that number. So somebody do this in their calculator. I get, well, I might have done, yeah, somebody give me the complement because I did the whole thing. I typed it in all together. What is binomial CDF of 30.37 and 15? Somebody tell me. Is it 0.94 or something? Good. What is it? Let's go. Point what? 94. 99. 36. And it keeps on going. So if I want, that's 0.949936. Okay? If I want to know what this is, I subtract this from what? 1. 1 minus 0.949936. And I get 0.0500. That's good enough for government work. So let's go down to our test. 5 cents is what? What was our alpha? Then 10 cents. If the p-value is low, you reject the what? Reject the null hypothesis. And that is p-values. Now, before y'all start convulsing, what time's class over? Okay, it's over. All right, now, what we're going to go over Tuesday, I don't want you to do any homework, okay? You're free for the weekend, okay? I don't want you to do any homework, but Tuesday, we're going to go over the next ones, the next type problems. And all I'm going to give you on homework, I'm going to cut all the homework off for chapter 10. Do 8 and 9. But I'm going to redo 10. I'm going to take all those. Is it 4 or 5 homeworks? 4. I'm going to delete all of them, and I'm going to put 1 homework. But it's going to be it's probably going to be after Tuesday before I do it. Okay? All right. Y'all get out of here and have a good day. And y'all are welcome for me unconfusing y'all. I hope you're not confused. I hope you're not more confused. No sneezing, no coughing.
Can't help it. What is this right here? When we ended, we got the complement of 0.5. But are we using this one in the p-value or the complement?
Is that the one we just did?
Yeah.
Okay. All right, we did this.
And then I did the complement.
Okay. And so that gives us this. So that is the p-value. I was trying to show you, but this freaking board. Okay. 0.05. Compare it to what? 10 cents.
Oh.
And it is what?
Okay.
Less than.
I was doing 0.37, not those.
Yeah. No, that's what you start with. That's information.
Now I got it.
You use your calculated value.
But that's 0.5 is less than 0.10.
So the p-value is low. So therefore. Remember I wrote that at the beginning. If it's low, if the p-value is low, where you been?
That's still therapy.
Oh, okay.
Okay, question.
Whatever that means.
Also, will you come over here?
What?
This problem right here,
Oh, let me cut the quarter off.
the supermajority problem.
Uh-huh.
I need to know where you click to get on the calculator to plug that in because I missed it.
Hold on 1 second.